Hello, everyone. What I'd like to do in this short video is an example involving doing computations with different time period interest rates with the same um, effective, the same actual interest rate, just with different time periods. That is similar to one of the collective homeworks and very similar to a former exam FM. So you have two annuities in perpetuity that have the same effective annual interest rate. So they basically grow in the same way, these two annuities. The first annuity pays $20 every 10 years, starting at the end of the 20th year, has present value 50. And the second annuity pays $2 at the end of each 6 months, starting at the end of the first 6 months. Right? Find the present value of the second annuity. All right, so really not too bad of a problem if you just do this nice and slowly. Right. So let's just draw the time diagram for the first annuity. And like always, not always, but like usual, time diagrams make this problem fairly easy. Time diagram is very quick. So I guess let's leave this here. Okay, so let's say J1. Yeah, let's say J second. Keyboard here. Okay, so let's say J1 is my 10-year interest rate. All right, so let's do my annuity one time diagram. Move this down a bit. Okay, so it's every 10 years, starting at the end of the 20th year. So it is in perpetuity, so this doesn't make sense here. It doesn't end. Right, so we start at the end, 20th year. All right, so this is in years. Okay, so this is fairly plug and chug. Present value here is just 20A infinity. Why I did that? That was a little weird. So I don't know what my interest rate is. That's fine, but this is just 20 over J1. All right, well, we have to bring this back 10 years. All right, so, and J1, well, J1 is my 10-year interest rate. So I'm bringing this back one 10-year period. So I'm just discounting by one period according to this J1 interest rate. So maybe it's a little clearer here if I just say first annuity time diagram. All right, so that. Okay, so it's 20. Well, this here you divide by 1 plus j. So I'm discounting this. All right, and we're given the present value is 50. So we have 50 is 20 over J1, 1 plus J1. So I would probably first divide everything by 10, makes life a lot easier. So it's 5 and 2. All right, so that means I'm going to distribute. It's J1 plus J1 squared. So 5 just looks a little nicer. J1 squared plus 5J1. And then subtract 2. This is 0. A very, very easy algebra. All right, so that means quadratic formula, and as usual, we do not include the negative solution. Really never, I don't think I've ever seen an exam FM problem with annuities involving negative interest rates. Actually, no, I've never. I mean, I've looked through almost every single one of the 400 or 500 SOA example problems, and even then, there's tons of. So you're not using a negative interest. Okay, so this is negative b plus. Usually it's a minus, but we're not going to use the minus. Usually plus or minus. So b squared minus 4ac, and be careful, this is negative, over 2a. All right. So plop this into the calculator, you get 0.3062. Okay. Now, we have everything we need for the second annuity. So if it wasn't clear why are we getting my interest rate for the first annuity, well, that's exactly what we need to get the present value of the second annuity. As long as we have the appropriate interest rate, then we're done. We just plug and chug. Right? And they both have the same interest rate. It's just two different time periods. So this is the interest rate for the second annuity. It's just we're given here, we have it as a 10-year interest rate. We need to convert it into a 6-month interest rate. So the easiest thing to do here, I would say, is, so you can go to the 1-year interest rate and then convert to a 6-month interest rate. But I think the easiest thing to do is the following. Let's say J2, I've done this before. I believe I've done this before. If not, then I apologize, but I think I've done this before. So let's say J2 is the 6-month interest rate. So it's the equivalent 6-month interest rate. This will be clear. Okay, so the question is, so right, let's say I invest $1. We want to see what happens using the 6-month interest rate and the 10-year interest rate to that $1. So I invest $1 and let it grow by this interest rate for 26-month periods. That's obviously the same thing as 10 years. So that's the same thing as taking my $1 times 1.3063, because we know money, this $1 is going to grow by 3.06, sorry, 30.623% every year. So yeah, sorry. Money grows by 30.623% every year. right? All right, so J2 is going to be 1.30623, 1 over 20 minus 1. And what do you get? 0.0134. And it doesn't hurt to do a sanity check. Make sure it's right. 1.01345. 20th. We basically get it's a little off due to rounding, but 1.3063 instead of 2.3, close enough. All right. Alternatively, if you really want, you could just use the equivalent effective annual interest rate. I don't know. It's a little more inefficient. I'll do it really quickly. You do it in 2 steps, and you can never go wrong doing this. So this is the equivalent effective annual interest rate. Then 1 plus I to the 10th. Yeah, same logic. If we're working with a 1-year interest rate, then $1 grows to 1 plus I to the 10th in 10 years. But we also know money grows by 30.623% every 10 years. I didn't write this down, but let's see, 1.30623, the 1 over 10, which is 0.1. Nice. So actually, I did write it down. 0.02707. And so now J2 is still the 6-month interest rate. Then 2 6-month periods of growth is the same thing as 1 year of growth. And money grows by 2.707% every year. As a percentage. Right, so this is 1.02707. Again, yeah. Again, just take really just taking the square root of this. Plus 1 square root of this. And you get the same answer, subtract 1.0134. So again, I think this is a bit inefficient, but you can't go wrong working with the equivalent effective annual interest rate for these kind of problems. All right, so let me do this. So I'm going to get rid of this. Give myself some more room. All right, so now we're basically. Every 6 months. So yeah, this is a skill you have to master. A lot of exam FM annuity problems involve changing time periods for annuities. And I think in general, it's an excellent skill to understand this. Money grows by certain percentage every certain period. How do you convert it to the same growth for a different period? And money grows by a certain percentage for a different time period. Extremely, extremely useful skill. All right, so two, et cetera, et cetera. Now this is just plug and chug, literally plug and chug, and we're done. It's $2 every 6 months, starting at the end of the first 6 months. So it's 2a infinity j2, 2 over 0.01345. So apologize for all the noises. 4th of July. Video done. 148.7. Yeah, there's something you can't read here. I don't remember Paint being this bad in terms of readability. Surprised, but yeah, okay. In the future, I'll have to do probably like at least 2 point. Yeah, even 2 point is much better than 1 point. So good to know. All right, well, yeah. Hopefully this helped, particularly for the exam problem. All right, so long, take care. Bye-bye.